A very good morning to you guys. Today we need to look at interrupts. Okay, we need to look at CPU interrupts. Alright, so we are saying when a program is running and the user requests for something else, I think I should write this down. When a process is executed, by the CPU, and when a user requests for another, and when a user requests for another process, then this will create a disturbance, and this will create a disturbance for the running process. This will create a disturbance for the running process. This is an interrupt. Okay, so we are saying a program is being executed. Let's say, for example, you're playing a game, okay? Then while you're playing a game, it means it's a program that is being executed. Then all of a sudden you just decide to minimize the game. Maybe you don't want your boss to see that you're playing games, and you just press the Windows button, this page pop. So a program was executing and you requested for another thing to happen. So you've actually generated an interrupt to the CPU. Okay? So basically that's the logic behind an interrupt. Now we need to look at types of interrupts. Okay, so in this lecture we are going to discuss only 3 types of interrupts as far as your syllabus is concerned. So in the Zimsec syllabus, we'll cover the first one, which is internal interrupt. Secondly, we cover the software interrupt. We have the software interrupt. And lastly, we have what is known as the external interrupt. Okay. So these are the three types of interrupts that we are going to discuss in this lecture. So I'll start with the first one, which is the internal interrupt. Now, what is an internal interrupt? So we are saying an internal interrupt is an interrupt that is caused by processing, for example, arithmetic overflow error. So is an interrupt that is caused by processing, e.g. arithmetic overflow error. Okay? The computer is making some logical calculations, and it realized that pama memory locations ainayo haichakwanisi kustore number iyoyo. The arithmetic overflow, we are saying the number cannot be stored anyway. Paitika error, paitika overflow. So this is an example of an internal interrupt. Okay, interrupt that are caused by processing. We move to number 2. We have what is known as the software interrupt. Okay, now what is a software interrupt? So we are saying software interrupts are triggered by the program execution errors. Okay, these are errors that happens in the actual software. All right, the actual code or the actual software is the one that triggers this type of error. So we can write these are triggered by program execution errors. These are triggered by program execution errors. Okay, so these errors is also got another name. These errors are typically called trips or exceptions. Okay, so you can write they are sometimes referred to as trips or exceptions. Okay, for example, we have the divide by zero exception, e.g. divide by zero exception. Have you ever noticed that on your calculator, if you try to say 2 divided by 0, you get an error? So it means in program a calculator, we have handled this exception. Zvakatonyorwa mcode a calculator, whenever a number is being divided by 0, it should produce an error. So the exception has been handled, or the error has been handled. Now, ukanyora code isina kuti kana munhu akatypa this inoita sei, ndo panoitika unongosina kuhandle exception. So that's when we have an error. Program ndo painonzi ya crash, okay, because you did not handle your errors very well. Like the divide by zero, it's actually an exception. Whenever a programmer are writing code, you should assume and anticipate that someone may write this, although he or she knows that it's not supposed to be like that. Someone may just feel like, I wanna add letters on calculator. I wanna say 0/5, and I wanna say times 5. Someone may just think like that. So your program should be in a position to actually handle exceptions like that. Okay? So it should actually generate something, not just leave it like that, otherwise it will crash. Okay? Last but not least, we need to look at external interrupts. External interrupts. Okay. Now, what are external interrupts? Now, external interrupts occur when an input and output device requests for any operation and the CPU will execute that instruction first. For example, when a program is executed and then we move the mouse on the screen, then the CPU will handle this external interrupt first, and after that it will resume its operation. So generally, external interrupts are generated by the external environment or the user. Okay? You move a mouse while the program is executing. The CPU will stop whatever, will stop whatever it was doing. It will actually pause and attend to the mouse which is being hovered. After that, it will resume its operation. Okay? So I can basically define this as occurs when an input and output device, when an input and output device request for any operation, and the CPU will execute that, and the CPU will execute that instruction first. For example, e.g., when a program is being executed, is being executed, and then we move the mouse, and then we move on the screen. Then the CPU will handle this. Then the CPU will handle this external interrupt first. This external interrupt first, and after that it will resume with its operation. It will resume with its operation. Okay, that is an external interrupt. Now, last but not least, we need to justify why computers use interrupts. Okay. Now, why do you think computers or CPUs use interrupts? Now, the first thing is that they give user better control over the computer. So they give user better control over the computer. What are we saying here? We're basically saying if ever there were no interrupts, for example, it would mean that when you're playing a game and your boss suddenly come in, you have to wait for that game to finish, and it will only minimize after it is done executing. So imagine you always have to wait for each and every process. Let's say you want to shut down your computer because maybe you want to attend a meeting or some sort. You have to wait for the program to finish executing whatever it was doing before you can actually switch it off. So that would be very inconvenient. So interrupts, basically, they give user better control over their computer. Okay? And the other thing is that it ensures that CPU will deal with processes immediately. It ensures that CPU will deal with processes immediately. Okay, so the CPU attend to processes immediately. Like, for example, peripheral devices like printers will send an interrupt, maybe that there is no more paper or there is no more ink. So if such an interrupt is generated, it will actually help the user to put maybe a new cartridge or to put some paper in the paper tray of the printer. Okay, so the processes will be attended to immediately. All right. Then the other thing that I wanted to discuss is the issue of priority. The priority of interrupt. Okay, what you should know about priority is that even though there is an interrupt that is executing, if another interrupt of a higher priority comes in, the one that was currently executing will actually stop and resume later. Someone may ask, what do you mean, say? Let's say you have an interrupt like maybe, what can I say, for example? You're copying files, okay? Let's say you're copying files from maybe the flash to the computer, all right? You've generated maybe an interrupt while the computer was doing something. You just decide to copy files, okay? So whatever you have done is now executing. You interrupt, do I execute? Then the battery, like let's say in the case of a laptop, battery robva rapera moto, robva ragenerator interrupt yaunomboona kuti kana uchishandisa computer inoti tu power yapa 7% or whatever. It's actually an interrupt inobva kubattery, right? Now power interrupt yakadaro, battery kupera kwaro kune higher priority than mafiles auri kukopa. So kana power yasvika pekuti haichaiti, the computer, the battery send a signal to the CPU rekuti we are shutting down. No matter whatever you are doing, battery ramo harichagone withstand my operations. So that's an example of a higher priority interrupt. Or maybe your computer is operating, or press the power button continuously, single release. The computer will switch off. So the power button has a higher priority than any other interrupt you can think of. So panebam pekuti interrupt is actually running, then you press it or magetso bhaenda kana iri desktop inobva yadzima ipapo ipapo. So it's an interrupt that has got a higher priority. I'm sure I have made sense here. So thank you very much for watching, guys. I hope you've enjoyed this tutorial. Should you have any questions, please don't hesitate to let me know. It's 0784 002 002. And also don't forget to subscribe on my YouTube channel. Just put a like and press the subscribe button. Goodbye.